Okay, so the area of a circle isn't 2 pi r. Dimensionally, it's incorrect. E.g., if r is in centimeters, then 2 pi r is in centimeters. But area is in square centimeters, or generally units of length squared. Think of a rectangle. You multiply length times width. You multiply, if the length is in centimeters, 5 centimeters times 7 centimeters gives you 35. It doesn't give you 35 centimeters, it gives you 35 centimeters squared. The area of a tile on the floor, they're 1 foot by 1 foot. The area is not 1 foot, the area is 1 square foot, or 1 foot squared. Okay? So just with those two examples, you can understand why that can't possibly be the area, right? Pi r square. Pi r squared, which is incorrect because pi aren't square. And this says pi r square. Okay? And that's a mnemonic, but it makes it easier to remember. You should also be able to derive it, and I'll probably do that at some point. And of course, we can derive it easily using calculus, but it can be derived without calculus. You just slice the circle up into pi-shaped regions and do a lot of them, and then stack those regions differently, and they'll have area r by pi r, not 2 pi r. And pi is ratio of circumference to diameter, okay? So pi equals circumference over diameter, which is circumference over 2 times the radius, right? Because diameter is 2 times the radius. So the circumference is 2 pi times r. Yeah. Multiply by 2r, you get this. So what you gave me was formula for circumference. And they're very similar. If you just remember formulas and think in terms of formulas, it's kind of difficult after after a couple of years not having used them to confuse 2 pi r with pi r squared. Each one has a 2 and a pi and an r. Where do they go? Well, if you don't understand the distinction and don't understand the definition of pi, or don't invoke the definition of pi, and most people don't remember the definition of pi as a ratio of circumference to diameter, then you're going to have a hard time distinguishing these. And you're maybe going to confuse them, although if you remember this, you know what this means. Okay? Also, dimensionally, anything that gives you an area had better give you dimensions of length squared, and this doesn't, and this does. Okay? So you really should remember this from now on. I mean, it's just part of cultural literacy. And I'm serious about that. Okay, so let's see how we use this. Okay, so how do you calculate the cross-section of this disk? Cross-sectional area is, well, cross-section's a circle, so the cross-section's the area of the circle. So now that we have these ideas, right? So now what's the volume? Okay? Now that's a perfectly good formula. It's a formula for area of any cylinder. But I don't want to remember that as a formula for the area of the cylinder. I want to think of the area of the cylinder as cross-sectional area times altitude. Because this is more general, and if you have a cross-section that's not a circle, you can still find the volume. Whereas this is limited to a circular cylinder. Completely ridiculous, in my opinion, to teach anybody with an IQ over 98 to memorize this as opposed to this. Okay? Now, almost half your population has an IQ under 98, which makes it complicated. What do you do in a class when you have a fairly typical cross-section, okay, of people, some of whom can only function at the level of memorizing formulas? Well, you teach them to memorize formulas because that's what the SOL asks for. And you don't teach the people who, you know, the 50% of your people, I think more than 50% who can understand this and apply it. So you get to calculus, and we got to digress for 20 minutes about this stuff, right? Now, I could have just laid the formula on you and gone on, but it's not going to help, as you're going to see.